Okay, we'll probably get started. Looks like most people are here. Yeah, my name is Cam. I recognize most of the people in this room, so yeah, if I haven't met you before, hello. And yeah, this is going to be a relatively high-level boot camp on what Redux-Observable is, as well as a bit of a shallow introduction to RxJS, because I'm going to be showing code samples. A bit of a disclaimer is that this is not a boot camp intended to teach you RxJS. It's definitely something that you should probably go and learn at your own pace. I will link some really good like tutorials to get you started with your own learning as well. But generally, this will help you kind of understand how it fits into the stack and what sort of problems you're going to be solving using Redux-Observable. So yeah, before I launch into it, I just want to kind of gauge the room's familiarity with the existing like React Redux stack, so minus any sort of asynchronous behavior. So could I get a show of hands for people who use React and Redux every day as part of their job? Okay, that's awesome. How about people who might use React every day, but not necessarily a state framework like Redux? Okay, a couple more people. And then people that are just kind of familiar with the ecosystem, or they've used React and Redux for like pet projects, that sort of thing. Yeah, a couple more. And yeah, finally, people who aren't familiar with React or Redux, like at all. Okay, just a couple. So yeah, apologies to those people. I'm going to be doing like a very quick whirlwind overview of the React Redux flow, just so that we're all kind of on the same page to get to the exciting and difficult part, which is Redux Observable. But yeah, if you're starting with the hard stuff, if you actually go and learn React Redux, it's going to be a breeze compared to this. So yeah, that's fine. So yeah, so this is basically a diagram, a very simplified diagram of the React Redux flow on the right here. You can think of your view as your React components. I like to think of them as functions that just take your application state and return you a rendered view. And so when you kind of hook up Redux, it gives you like the concept of a global application state, and you're going to bind like UI callbacks to dispatching actions into Redux. And these actions are going to run into Redux reducers. And these are just little pure functions that take the previous application state, the action that was dispatched, and they're going to return you a new application state based on processing the action that was dispatched. And kind of the core principle of Redux and what makes it so nice to work with and gives such good dev tools is that reducers have to be pure. So you can't perform any side effects in your reducers, and they also need to be idempotent. So if you call a reducer with the same state and the same action, you're going to get the same resulting state as a result, no matter how many times you call it. And so yeah, this is what gives you things like time traveling debugging and like very easy predictability, basically all of the reasons why Redux is kind of the accepted state management framework for React. But this kind of begs the question as to where do I actually perform my side effects? Where do I actually do things in my application that need to affect changes to the outside world or receive data from the outside world? So some examples of side effects would be things like network requests, analytics, any sort of logging, basically anything that doesn't synchronously involve a change to your application state. It might involve a change to your application state later on in the case of something like a network request, but it's not something that you can just immediately process when like you receive a request from the view, for example. And there's kind of a broader question that Redux doesn't have a good answer for, which is how can I compose simple UI actions together in order to create actions that are more meaningful to my application state? And by meaningful, I mean things that can just be immediately reduced. And so I use drag and drop as an example. Your simple UI actions might be things like mouse down, mouse move, mouse up. But in order to actually update the position of a thing on my screen, I need to kind of have some awareness of what the currently selected card is, or whether my mouse is even down. And so if you just have those simple UI actions, if you try and kind of compose this logic, it's going to leak like implementation details all over your Redux state. Things like what was the currently selected card, like is the user holding the mouse down? And like these are things that I don't personally think belong in your Redux state. Ideally, it should just be like a very simplified version of something you can derive a view from. And so stuff like that is really about tracking like a long-running process that might occur within your application. So there's no real good answer for that in Redux as well. And so when we made core boards, we weren't fortunate enough that something like Redux-Observable or Redux-Saga existed at the time. So we kind of rolled our own solution that's very similar to Redux-Thunk, if you're familiar with that. But effectively, it's a way that you can just, instead of dispatching an action, you can dispatch a function instead and just do any side effects you want and then emit actions as a result of your side effects. The main problem with this is really good for like simple isolated network requests and that type of thing, but you kind of lose sight of like what actions have actually occurred before me, like where am I within this sequential process? And that's something that both Redux-Observable and Redux-Saga have a really good answer for. So yeah, how does it look sitting next to the existing Redux flow? It's basically this like little isolated box that sits next to the normal like dispatching action, reducing, rendering my view flow. And basically it's an isolated box that takes all actions over time, time being very crucial, as input, and it has the ability to emit new actions that will also just feed into the normal flow. And so because it's just dealing with actions as a contract, it sits really cleanly next to Redux, and things like time traveling and all of the good things about Redux still remain intact because your reducers remain pure. So yeah, before I dive into the specifics, I just want to kind of gauge how familiar you guys are with the concept of a stream, and more specifically, an event stream. So could I just get a show of hands, people who've used the Java 8 Streams API, for example? Oh, okay, that's really good. Something like Lodash or underscore? Awesome. And then just the functional primitives, things like map, filter, reduce, that sort of thing. Yeah, okay, awesome. And so before I started like kind of programming in the FRP paradigm, I typically used streams or like functional primitives like as a substitute for a for loop. So I had like a collection of things in memory and I want to transform them in a way that I don't have to break out into a for loop and like build up a new state of things over time. It's much easier to read like a chain of functional primitives when you're transforming something, and it's also pure. Which is really important and really good. So if you kind of take this concept further, FRP, or functional reactive programming, is a paradigm that lets you operate on a stream of things that like might not even be there yet, but you operate on them in the same way as you would as a collection that exists in memory, which is a really powerful paradigm because it means that once you've written your logic, you've kind of defined all of the behavior that can and ever will happen in your application, like all of the plumbing is there, and then when the interactions are actually occurring, you just have stuff running through that plumbing, but you're not moving anything as the application runs, which is really cool. But yeah, the official definition of a stream in this sense is a sequence of ongoing events ordered in time. And the time part, again, is really crucial, and it's going to keep coming up again and again. It's kind of one of the core things that you'll be dealing with when you're programming with streams. And so this is kind of a good opportunity to segue into what I think is a very useful visualization of operating on streams. And this is called a marble diagram. This is a really simple marble diagram dealing with the merge operator from RxJS. And basically how you read these things is you have two or more input streams, or sometimes there's one input stream. You have the operator, and then you have an output stream. And so the important part to notice is that it's maintained the time semantics of when things were happening on your input streams, and different operators will obviously handle these time semantics differently. So if I actually go and show you an example of some marble diagrams. So this is the merge one. This is a site called rxmarbles.com. It's fantastic because its marble diagrams are actually interactive. So you can move things around on your input stream and it's going to actually be invoking that operator, and you'll see the result of the output stream. Hopefully I don't get another one of those. And so if you're looking at a marble diagram and you don't really understand what the operator's doing from looking at it statically, you can just have a play around with the input streams and it's going to become really apparent what the purpose of that operator is. So yeah, does this make sense? Does everyone kind of grok what a marble diagram is and why they're useful? Cool. And so there's actually even simpler ones. So this is your map primitive, and it's just like mapping over a collection, except obviously you're maintaining the time semantics of when things were emitted on your input stream, where you can just perform a simple transformation and I'll get the transformed value emitted on my output stream. There's also marble diagrams for things that are a little bit more complicated, something like combine latest. So combine latest is anytime any of your input streams emit a value, you're basically going to take the latest value from all of your input streams and feed them into a function where you're able to combine them in any way that you see fit. Don't worry too much about the specifics of combine latest. I just want to show you that marble diagrams are useful for even more complex operations. And the first time you look at this, you might not understand what it does, but you absolutely would if you started moving things around and having a play with it. So yeah, that's marble diagrams. So yeah, we kind of touched on RxJS. Those were specifically marble diagrams for Rx operators. But it's kind of an important distinction to make is that RxJS and FRP are not the same thing. So RxJS is an implementation of FRP, and there's tons of them. So even just in JavaScript, you have things like Bacon, Kefir, Highlander, Rx, obviously, Xstream, there's probably like a dozen more. But RxJS is definitely the most mature, and it seems to be the one with the most like developer mindshare. There's bindings for Rx in pretty much every language that you can think of. I'm pretty sure Rx Java is just like a standard part of the Android development stack as well. So it's a very like well-regarded, mature library, and so it makes sense to use it here because, yeah. So yeah, I like to think of RxJS as like Lodash for events in the sense that it's just a bunch of convenience methods and utilities to help you deal with programming with streams. And it's important that you kind of separate that concept from FRP and stream programming in general. RxJS is there to just help you with convenience operators. It's not there to dictate like what stream programming is. And yeah, this is the hard part of learning to program with Redux-Observable, is that you will end up having to learn RxJS. And for a lot of people, if you're not already familiar with FRP, you're going to kind of be learning a library and a new paradigm at the same time, which is pretty hard to do. And it's going to take a while before it clicks, but it will click. And then you're going to want to write everything in this way because it's very declarative, and I think it's very easy to reason about. And yeah, there's a shitload of operators. There's something like 60 to 70 operators in RxJS. Just as an example, I think the issue app we use like 4 or 5. There's going to be some that you like very commonly reach for things like making a network request or making a GET request or doing things like debouncing. But you're pretty much guaranteed nearly because of how many operators there are, that if you can draw a marble diagram that models your specific problem, there'll probably be an operator that solves it for you. And so multiple times I've like rolled something more complicated myself using the operators that I already know about, only to find 2 weeks later that there's an operator that solves my exact use case. And so it's kind of a good idea just to, even if you don't understand every operator, to have a general idea of what kinds of operators or the families of operators that are available to you before you dive in and start coding. So yeah, we've touched on Rx, you kind of know what a stream is, we know what Redux is, so what is Redux-Observable specifically? I showed you how it fits into the flow, but what is it and what is it doing under the hood? So Redux-Observable basically introduces a new primitive called an epic, and an epic is specifically a function that takes an action stream. So if you ever see this $, just read it as the word stream. It's kind of like a convention that you want to name a variable that is a stream because we don't have types, or maybe some of you have types, but we don't have types. And you return a new action stream, which will be your output stream. And anything emitted on that output stream will just feed back into the normal Redux flow. And so kind of at a philosophical level, this is really powerful if you think of that stream of actions as your user. It's like all of the interactions that your user can perform in your application over time. You've stored your user in a variable in your app. And that's not really something that you can do in many other paradigms. And I think that's really cool. So it's your job in an epic to operate on this action stream that's coming in. It's everything that will be dispatched through your UI, through Redux. You want to operate on this using RxJS operators and produce a new stream of actions that will be your output, and they will feed back into the normal flow. An important gotcha is that they will also feed back into your epics as well. Like every time you emit something from an output stream, it's going to go through the entire Redux flow. So there is potential to hit infinite loops if you're not careful, but yeah, it's something to watch out for. The coolest part about Redux-Observable is that you basically get to ignore what I think is the hardest part of learning RX. And when you go and look at the tutorials, there's going to be a lot that cover these specific topics. But things like managing subscriptions, the difference between hot and cold observables, you just don't have to care. Like you have a very narrow contract to be writing these stream operations in, and Redux-Observable takes care of everything else for you. So that's really good. Does that kind of make sense to everyone? Is there any questions so far with Redux-Observable? Okay, cool. Oh yeah, that spins. So that's their logo. So the RX logo looks like this, and then they've kind of put ducks in there because Redux, and yeah. So solving a problem with an epic. So let's say I have a new problem that involves some side effects or some composition. How would I approach actually solving that problem with an epic? And so the first thing you're going to do, which is a good idea whenever you're solving a problem, is to describe it in detail. What you want to do when you're using RX, though, is pay particular attention to any of the timey keywords that come up in your problem description. So to use drag and drop again as an example, because it's a really good one, like a drag move action that would actually be updating the position of something on your screen. You can define one of those as being when the user clicks down, every mouse move until the user lifts their mouse. And so those keywords like when and until are kind of going to point you in the direction of the RxJS operators that are going to be a huge help to solving your problem. And yeah, take until is a perfect operator for doing drag and drop. You can do it in like 2 or 3 lines. And so, yeah, you're going to want to isolate your time semantics, try and draw marble diagrams to illustrate the problem that you're trying to solve. It will help, and you'll probably catch your own edge cases in the process of trying to visualize it. And then you're basically going to want to do a comparison between your marble diagram and the RxJS documentation or the existing marble diagrams. And this step will become easier and easier the more familiar you get with the library, but yeah, that's probably the hardest part of this at the moment. And also a massive hint is that test-driven development can really help, especially if you're unfamiliar with RX, because even though it's this little black box, it has a very clear contract of inputs and outputs, and so it's inherently very easy to unit test. So I'd strongly encourage you to write your unit test before you write the epic, because then you just have a clear win condition. And that's just test-driven development in general, which is a good idea. And so we have a utility in Jira Frontend. If any of you aren't working in Jira Frontend, I can link this utility. But it's called test epic. It basically takes 3 functions as parameters: arrange, act, assert, which is like a normal unit test. In your arrange method, you're going to set up any mocks for the side effects that your epic might be performing and actually create your epic and return it. And then in the act method, you're given the input stream. And so it's your job to basically push things onto this input stream, like you're pretending to be Redux or pretending to be your user. And then you call complete on it when you're done, because streams live forever and you need to actually tell it when you're finished. Otherwise, Mocha will time out or not finish your test, whatever. And then that complete kind of triggers the running of your assertion method, where you just get a flat array of all of the actions that came out the other end of your epic. So using a network request as an example, you're probably going to put something like a request action onto your input stream. And then in your assert method, you're going to expect that you got a single success or failure action coming out the other end. Without knowing anything about the epic underneath that, I kind of know that that's the behavior that I'm expecting from that epic. Okay, so we're going to look at some code samples. Big disclaimer, it will look very alien if you're not familiar with RX, but we'll kind of walk through some simple ones and then a not so simple one line by line, so you can just gain an intuition as to how FRP programming feels. So yeah, we'll start with the simplest example. Reality is 9 times out of 10, you probably just want to do a network request in your app. So it's probably a good example to start with is a very stripped down GET request. So this GET request isn't doing any debouncing. It does handle concurrent requests, which we'll get into. But yeah, it's basically responding to a request action and emitting a success or a failure action with the appropriate payload that came back from the server. And so the export here is the actual epic. So I'm taking the action stream, which is my stream of any action that was dispatched through Redux. And I also get access to the Redux store. And this is really important because you can call getState on it at any time to get the state of your Redux store. So if you have things like your logged in user or like what pagination you're up to for a network request, something like that, it's probably going to exist on your Redux store, and so you can access it in your epic. And so on this first line, this is very typical of what an epic will look like. I'm dealing with all of the actions, but I'm only interested in one in order to kick off my request. In this case, the fetch license details request action. And this is just a normal action type from Redux. And so whenever I receive one of these, I'm going to do something called switch map. This is part of, in my opinion, the most scary family of operators in Redux, in RxJS, sorry. But if you understand these, they're also the most powerful. So I like to think of them as like kind of forking like into an asynchronous process. And typically this is what you're going to do immediately before you perform a side effect. And what its contract is that you give it a function that itself returns an inner observable. And so the idea is that I'm kind of going to fork off this inner stream. I'm going to perform my network request, and then I'm going to map it into my success or failure actions. And what switch map will do is basically flatten that inner observable so that instead of having like an observable of observables, which is like an absolute mind bender, it just flattens this into a single stream of actions, which is the contract that you need to adhere to as part of an epic. What makes switch map really special and why it's probably going to be your go-to operator for making GET requests is that it will handle concurrent requests for you for free. So if you imagine that I have one of these actions come through and I'm actually performing my GET request, so I'm sitting somewhere in here fetching something from a network and waiting for a response. If I receive a second fetch license details request while that first one is still being processed, I effectively throw away the first one in favor of the new one. And so you can guarantee when you use switch map that you'll never receive stale data, and you don't even have to like think about that. You will test for it to make sure that it works, obviously, but yeah, switch map, concurrent requests for free. It is important to note that it's probably only for GET requests, because if you're doing a mutative request like a post or a put, you probably are interested in explicitly every response that you get back from the server, so you can tell the user if something went wrong. And in that case, you would use merge map, otherwise known as flat map. And it's exactly the same. It has like the whole inner observable that it's going to flatten, but it won't throw away the old one. It will actually maintain all of the old inner streams and emit all of their results on your output stream. The final one is concat map, which is you will guarantee the sequence in which you receive those responses matches the sequence of when you have the inputs. And so that's usually the case if you want to like avoid any sort of race conditions. So if my first request actually takes longer than my second request, concat map can give you that like ordering for free, which is really helpful. So the next line here, so we're in a little inner observable. This has kind of been abstracted, but you can think of it as just a window fetch. We have a fetch JSON stream wrapper around window fetch, and this just turns a promise into a stream. And so a promise is, you can think of it as a very narrow subset of what a stream offers you, in that a promise explicitly emits a single value and then completes. And so by turning a promise into a stream, you're turning it into a stream that will emit one value and then complete itself. And so that's what this wrapper does. So this return will be an observable that's going to emit the results or the resulting payload of my fetch request. So after I've done that here, I'm now mapping over it. So I'm assuming that I've got the results of my request feeding into here, and I'm just using a normal old action creator from Redux. In this case, the fetch license details success action creator. And so it's going to take as its argument the payload that it received from the server. It's going to dispatch a normal Redux action, and the whole flow is just going to continue as normal. So I'll get into this a little bit later. The way that error handling works in RxJS is a little bit funky, and it's definitely one of the gotchas. But basically, if anything goes wrong in this inner observable, I'm going to replace that entire inner observable with this one instead. And in this case, that's just going to be an observable that emits a failure action. And so switch map's going to flatten that into my output stream, and it's kind of a way of guaranteeing that I either get a success action or a failure action based on what happened in the network. Does that make sense to everybody? That was probably a lot. Kind of. That's good. What might actually make it a little bit clearer is if we look at the tests for this thing. So the first test is the happy case. I should emit a fetch license details success action with the expected payload when my REST call succeeds. So I'm using my test epic utility here. In the arrange method, I'm mocking out the call to fetch JSON and I'm simulating a successful network request. And then I'm setting up my epic and returning it to the arrange method. And then in my act method, I'm pushing a fetch license details request action onto my input stream. So this is simulating that the user clicked refresh or something and actually asked for a request. And then completing it because that's all I'm interested in doing. And then in the assert method, I'm making sure that because I mocked out a successful request, I get a successful action with the appropriate payload. Similarly, for the sad case, we mock out a failing network request. We do the exact same thing in the act method, which is pushing a request action onto my input stream, but I'm expecting that I get a fetch license details failure here instead. And so you can imagine if this more granular, handled errors in a more granular way, you could expect different failure actions with different payloads based on what went wrong with the request. And so you could write unit tests for that. And so this last test is actually testing the switch map behavior. And so this is basically, and it's also a good idea when you're testing something like multiple requests that you make a test that has a failing thing first and then a successful thing after. The reason for that is the gotcha that I mentioned earlier with the way that error handling works. If you don't handle your errors in this inner stream and instead it bubbles all the way to this output stream, or you get a runtime error that bubbles all the way out and it's uncaught, your epic will close. And well, it will complete. And so effectively it won't be running anymore. And so if you don't test that it survives a failure, you can get into a case where your epic just dies, like at the runtime of your application, which really sucks. It's a bit weird that RX chooses to do it that way. But I think I was answering one of your questions related to that had a catch at this like top level of the epic, and it will result in your stream closing. So it's definitely something to watch out for. And so this test is kind of checking that. So it's doing a failing request, and then it's doing a successful request. I'm pushing my two request things. The reason I have to do a set timeout here is because of switch map. If I did it synchronously, switch map would just throw away my first request and it wouldn't actually get to the point where it hit my mock, or if it did, it would be because of a race condition. So I'm just basically forcing myself to be on the end of the call stack to make sure that that first mocked request actually ran, and I'm doing another request. And then I'm making sure what came out the other end is a failure and a success action, specifically in that sequence as well, which is another important thing. So yeah, do these tests make sense? Does that make it kind of easier to understand what the epic's doing under the hood? Okay, good, I'm seeing nods. All right, so let's go a little bit more complicated. So this epic, I might demonstrate the behavior first because it'll make it a little bit easier to understand. So this is the epic that involves fetching the suggested assignees in our assignee picker when the user's typing something. Our mock request for this doesn't actually match the query. We just get the same results back every time, so you won't actually see it filtering the results. But just so you kind of understand what's happening, it's the epic that's populating that like autocomplete box. So all right, so the first thing I want to draw attention to in this epic is the fact that you can kind of break up a particularly complicated epic into these little mini sub-epics, and you can just merge them together because they're just streams. You can put them all on a flat level, and they're all going to operate in the exact same way on the exact same action stream. So you can basically separate an epic on any dot. So if something makes sense as like an isolated unit, you can totally just put it in a variable or put it in its own function declaration and treat it in isolation, and then also test it in isolation, which is a really handy thing to do. And so we have these two little sub-epics here, and what these are doing, so that's actually the second interesting thing about this. This is like the core functionality of the epic. This is the thing that's actually doing my network request. And you'll notice, like the example that I showed you earlier, it's filtering for this specific action type, the fetch suggested assignees request. What's interesting about this epic is that that request never comes from the UI. That request action actually comes from either of these two little sub-epics. And that's because we have generic actions that operate on a field without knowing or caring what that particular field is. So we have just simple actions that will fire whether I'm updating the summary or the assignee or the description. And these are things like edit field update and edit field begin. And so I can use these two little sub-epics to turn an update on the assignee specifically, or when I begin editing the assignee, into a request, without the UI having to know that a request needs to take place. And that means that this epic actually holds all of the logic necessary for fetching the suggested assignees and populating that box. None of it leaks anywhere other than this particular epic, which is really nice in order to like reason about any bugs that it might have, but also for testing purposes as well. And so, yeah, these two little mapping epics, they're looking at the payload of my edit field update action. And if I was updating the assignee, I'm going to turn it into a fetch suggested assignees request. When I say turn it into, I don't actually mean that I'm changing the action. That edit field update will still go all the way through the Redux flow, but I'm additionally going to have this request action dispatched as well. And the same deal for edit field begin. So that's when the user first clicks into the assignee field. I also want to fetch some initial results. And so, yeah, actually, I might show that kind of happening. So you can see on the edit field begin, I got my fetch suggested assignees request, and that was coming from the little sub epic. And then I'm doing the network request and getting a success back. And so we'll look at the second part of that epic now. I keep doing that. All right, so this is basically identical to the example that I showed you earlier. It's filtering for a request action. You can ignore this crazy second line. We'll get back to that. It's doing a switch map so that I handle concurrent requests. I never get stale data based on the user's query. It's performing a network request. In this case, we haven't abstracted over fetch.json. We're just calling it directly. So all of this logic is just about getting all the things I need to actually make the network request. I do the network request, and then on the lines after, I can assume that I got the payload back from my get request. So I'm doing some transformation so that it is in a format that I want for my Redux state. And then I'm mapping it to a success action. And if anything goes wrong in the request or in the transformation, I'm instead turning it into a failure action. So this is the exact same as the example that I showed you before, except debounce. So this is really cool, and it's kind of, it demonstrates the power of programming in FRP. Because you have this clear concept of time, you can do things like debouncing in a single line. And so the way that debounce will work is it's basically going to pause on that line. So anything that comes through, any request actions that make it through that first filter, will basically sit on debounce for the amount of time specified by fetch debounce time. In this case, it's a second. And if any other requests come within that time, it's going to reset that timer and continue to pause and wait for other things. And so I only get to this switch map if I've received a fetch suggested assignees request and then no more for a second. And so we can kind of demonstrate that behavior. So I've got it set as a second. Okay, so we go, where's my dev tools? So they are. Okay, so we go into here. I'm pausing for a second, so I actually get my success come back. But if I type quickly, you will see that, yep, doesn't scroll for me automatically. You'll see that I'm getting these pairs of updates and requests. It's probably a little bit weird that we're debouncing the actual request action because a network request isn't actually occurring because that happened after the debounce line. But you can see that I'm not getting any failure or success actions. I'm just basically stuck on that request line until I paused for a second, in which case I got the request and then the subsequent success. So yeah, one line debouncing is pretty powerful. But like all things, it's a good idea to test it. So we have some tests around debounce behavior. This kind of illustrates why breaking down your epics is a good thing. You'll notice that they weren't actually separate exports, but I can exercise their behavior as if they were independent epics. So I have two test cases here that are just checking when I do an edit field update on the assignee ID, I get a fetch request coming out of the epic. And the same deal with when I begin editing the assignee, I also get a fetch request. And then just for completeness, when I edit the summary, I don't get anything coming out the other end. And then we have very similar tests to the first example where I'm actually exercising the network request behavior. So I have like successful result mocks, failed result mocks, and I'm making sure that when I have a successful result, I push my action on, I get the success action come back. Same deal with the failure, but with a failed mock and a failure action. And then these are kind of interesting. So here I've specified my fetch to bounce time, and I'm making sure that if I do 2 requests within that time, I only get a single response coming out the other end, and I verify that my actual fetch stub, which is the thing that makes the network request, was only called once. This is different to the switch map behavior. So if I have a delayed request, if I say that the request itself actually takes some time to run, and I deliberately wait for longer than my debounce time, I'm still making sure that I only get a single result, even though my network request was called twice. And that's because of the switch map basically discarding the results of the first request. Cool. Yeah, that was probably even more. Does anybody have any questions about the fetch suggested assignees epic or its tests?
On your test, you had a waiting of 5 milliseconds.
Yep.
Is that, are you controlling the timing, or are you relying that the CPU is going to run it fast enough to actually, within 10 milliseconds, to actually complete both requests?
Yeah, so in this particular case, I think we actually have it hard-coded, but if you notice, the epic itself does take the debounce time as a parameter.
Yeah,
so yeah, we can control it. Unfortunately, I'm not sure if it's a bug on RX's end or Sign-On's end, but fake timers don't work particularly well with RX. I think it's a known issue, and it is really annoying at the moment because you actually need to use real timeouts, which is like terrible for your tests. But eventually that should be fixed, and you'll be able to use something like sign-on fake timers to mock your debouncing. But yeah, that sucks. It's definitely another gotcha. All right, so moving on. Cool. So yeah, I've mentioned a couple of these just in passing, but RX has gotchas. These aren't necessarily FRP gotchas. They're usually things that RX has kind of decided to do that might differ from other stream libraries or might seem counterintuitive. And I've definitely been bitten by them a lot before. The biggest one is error handling. Basically, anytime you know that a runtime error can occur in your stream, treat that as a massive red flag to be super careful to make sure your stream is robust enough to survive. Because it seems really strange that streams can live forever, but if an error occurs, they just silently die. Just be really careful about that behavior and write tests for it, definitely. The other one is that debugging, I don't necessarily consider this a bad thing. It's just different if you're coming from like a more imperative style of programming. The way that like nothing's really moving at runtime, you just have things like running through this plumbing. Log-driven development is definitely the way to go. So there's this little do operator in RX that basically just allows you to perform a side effect on any value that flows through that part of the stream. And so 9 times out of 10, your problem's going to be either my stream isn't emitting anything or it's emitting the wrong thing out the other end. And in order to isolate where your problem is, you basically want to use a do log and move it through each of the operators and make sure all of them are receiving the input that you kind of expect them to, and that your console logs are even running at all. Because if they're not, you might have some sort of bug in your, like, how you reason about the time semantics of your problem. All right. Yeah, any questions on those gotchas, on error handling or log-driven development? If you set up your IDE and you do test-driven development, you will hit breakpoints for things. Sometimes a little funky whether breakpoints work or not when you have like this little one-line function like this. I've noticed it sometimes work and sometimes not work. But if you have something that's a little bit more broken out, like the inner observable creation in that switch map, if you put a breakpoint there, it will hit it. So yeah, test-driven development plus using something like VS Code that has like inline breakpoints can really help. Cool. So that's pretty much it in terms of the content. I have this last slide. I will post these links in our Redux-Observable Bootcamp hip chat room. I very, very strongly recommend the first one if you're unfamiliar with FRP. It's kind of like a grassroots introduction, like written in layman's terminology, to what is reactive programming, like why it might seem so complicated initially, and it kind of dispels a lot of like the magic and the intimidation of using something like RX. It's written by a guy called Andre Stoltz. If you can find anything like written about reactive programming by that guy, it's really, really good. He's one of the main contributors to RX, and he just explains things 1,000 times better than I possibly could. And so, yeah, he's a very handy resource in his own right. And he actually runs that free Egghead RxJS series that I have linked as well. There's actually multiple series run by him, but I'm not sure if the other ones are free or not. They're not? Is that one free?
Most probably.
Okay. Yeah, definitely watch that one at least, and then bug your team lead for an Egghead subscription like I did so that I could watch the others. But yeah, he will kind of take you through like creating your own observables as well as implementing your own like custom operators. And as soon as you see that, you realize that there's not actually that much magic happening under the hood. A lot of it is just using JavaScript things like set timeout and set interval. And it's just, it's kind of showing you that there's nothing to be afraid of when you're digging into the internals of something like RX. Because generally when you're learning to program with it, it does feel very, very magical. And if you have some sort of intuition as to what's happening under the hood, it makes it a lot less scary. And yeah, the last one is probably less important for learning, but it's really good motivation for why we chose Redux-Observable. And so it's by a guy at Netflix. So if you weren't aware, Redux-Observable actually came out of Netflix. They're big fans of RxJS. They were big fans of React and Redux, and they kind of wanted to put the two together somehow and came up with Redux-Observable. And there's some really good examples of like stream problems that can be very easily solved in streams that are inherently either impossible or incredibly complex to solve using any other paradigm. And so a lot of the examples I showed you today probably didn't illustrate this because they would use much more complex features of RX. So I stuck to things like making network requests. But there are situations that you're going to be very glad that Redux-Observable is the abstraction that we chose for that. But yeah, that's pretty much it. Does anybody have any questions at all about anything? Yeah. Switch map. Yeah. Is there a marble diagram for it? I think they gave up on RX marbles, but I think the docs it's hard to draw. It's really hard to draw any of those like higher order observables. I think the documentation tries, but it looks weird as hell. But let's find one. Oh yeah, so this is another gotcha. Actually, I should have mentioned that RX just very recently did a full rewrite from RX4 to RX5, and there are breaking changes. So be really careful. I'll link the correct docs. Currently, the RX4 docs still come up higher in the Google search results. But basically, if you see purple, you're in the right place. If you see a GitHub page, you're in the wrong place. So yeah, make sure you're using the new docs. Most of it's the same, but yeah, there are some breaking changes. So please have a marble diagram. Oh, it has one. Okay, let's try and understand what this is. So yeah, they've tried to model that inner stream as that little stream of 3 tens. So it's like when I receive a 1, I'm kind of forking off and creating an inner observable that will emit 10 3 times. But you can see that the output stream just has the 3 tens on it. So the fact that it's kind of flattened that inner observable into like a flat output stream. But yeah, it's not as nice as some of the other marble diagrams, definitely. That's why I tend to think of it as like a fork. Like I would actually draw a line like coming from the 1 there to say that I'm explicitly creating another stream. And so my input in a way is a stream of streams that gets flattened into just a single like stream of values. But yeah, hopefully that helps. Probably not, but once you use these things like a fair few times, you'll understand it, and they are the hardest operators, like by far. All of the others are just doing transformations on an input stream. It's these higher order ones that are going to bite you, probably. Any other questions? Yeah, so I'm very glad you asked that, Michelle. So I did want to very briefly give an example of something that would be really hard to solve without using something like RX. And I really like their example for sequence equal. So if you ever imagine needing to implement like a multi-key keyboard shortcut handler, or a more fun example would be a cheat code, so like up, down, left, right, A, B to catch Pokemon, if that ever worked. Basically, this operator will do all of that for you. And if you weren't using streams, you would need some kind of like global array to handle like a timeout and like what the last like entered sequence was and like whether the next press is going to match the other thing. You can do it in like basically one line of RX. No, it's not really one line, but this is not using Redux-Observable, so it's actually setting up like the streams that it needs to operate on. But you can basically have a stream of your keyboard events, and you can have a stream being like the sequence that you actually want to match, which is code in this example. And your output observable will emit something when that sequence matches over time. And you have the ability to very easily add like a timeout to that using like a buffer to make sure that they have to like very quickly enter the cheat code, or more practically like the multi-key keyboard shortcut. And so if anybody uses Vim, I really like to imagine like implementing an entire Vim like plugin just using sequence equal so that I can catch things that are like entered over time. I think that would be like a fantastic abstraction. And I've looked at some Vim plugins code and it's horrendous and could be easily solved with something like this. So yeah, that's my favorite operator. Cool. Yeah, that's pretty much it from me. I'll probably turn the HipChat room into just like a general Redux-Observable questions and answers room. I love solving these things. I do have my own roadmap, so I might not be able to like work on it immediately, but I do really enjoy when someone has like a hard problem that hasn't really been thought of yet. Trying to solve it in like a clean way using RX is just fun. It's fun to do. Cool. All right. Thanks everyone for coming, and good luck.